Okay, chi-square test for relationship between two categorical variables. We can apply chi-square test to determine is there a relationship between two variables. The null hypothesis is that the two variables are independent. So already you know, using correlation coefficient, we can observe the relationship between two numerical variables x and y. Okay, now but if x and y are categorical, then we cannot apply correlation coefficient. In this case, we have to apply chi-square test to know the relationship between the two variables. Okay, now they are independent if the distribution of one criteria is no way depend on the distribution of the other criteria. The test only indicates whether or not any relationship exists between the attributes. It will not indicate the degree of association or the direction of relationship between the two attributes, as correlation of regression can do. Now, for example, in election polls, is there a relationship between voter genders and preference among candidates? Okay, so voter gender, male, female. So one attribute, gender, it may be male, female. Okay, and Y, candidates. So candidate 1, candidate 2, candidate 3, so on, candidate N. Now to know the relationship between gender and candidates, we have to apply this particular test. Okay, or to know the relationship between the color. Okay, color with religion. Is there any relationship between color and religion? Say color may be red, green, blue, black, and religion may be Christian. Okay, it may be the Sikh, it may be Parsi, and so on. Now, to conduct the test, a sample is drawn from the population of interest and the observed frequencies are cross-classified according to the true criteria. The cross classification can be displayed using contingency table. Okay, you can. So to apply the chi-square test, we have to draw a table. Suppose attribute A1, A2, A3. Say color red, green, and blue. Okay. Next, maybe the religion. Say religion 1, religion 2, religion 3. So we have to calculate the total of that. We can calculate the total. This is called contingency table. Now B1 religion, so assume this one is the religion, this one is the color. So A1 religion prefer color B1. Okay, now we have asked few people from religion A1, they are saying that they prefer color B1. Similarly, another religion, say A2 religion, prefer B1. Okay, A3 religion may prefer B1 also. So A2 B1, A3 B1. Similarly, religion 1 A1 may prefer another color B2. So A2 B2. Okay, so A2 religion may prefer B3 color. So A2 B number of A2 religion who prefer B3 is A2 B3 and so on. Okay, so these are our observed frequencies. So total, if you add all this, you will get A1. If you add all this, you will get A2. If you got all this, we will get A3. Similarly, if you add all these three, we can get B1. If you add all these three, you can get B2. If you got all this, you can get B3. So these are the observed. Next, we have to calculate the expected. Now, expected, we assume that these two are independent. These two are independent means, suppose probability of A1 and B1 if independent, that means what? Probability of A1 into probability of B1 if they are independent. Now what is the probability of get A1? So probability of A1, that is probability of A1 is nothing but A1 by n. What is n? N is the total number of frequencies, total number of observation n, and probability of B1 is what? B1 by n. Okay, now total number of person who follows they prefer the A1 B1, so we have to apply n into A1 into B1, that means n into A1 by n B1 by n, that means A1 B1 by n. So this is for the first cell. So here expected, so these are our expected frequencies. So here expected frequency A1 B1 by n, here A1 B2 by n, here A1 B3 by n, similarly A2 B1 by n. Okay, so we can get all the, so these are our observed frequency and these are our expected frequency. Okay, and so we have to apply the same formula, observed minus expected square by E, and E is the expected frequency and O is the observed frequency, and degree of freedom is R minus 1, degree of freedom is R minus 1, C minus 1. R is number of rows, so here number of rows are 1 2 3, number of columns are 1 2 3. Okay, and level of significance alpha, so it may be 0.1, it may be 0.5, and it may be 0.05. It's a right tail test. Okay, it's also a right tail test, so it is our theoretical value. So alpha degree of freedom R minus 1 into C minus 1. So if the value, calculated value, is less than this particular value, accept the null hypothesis. If it is more than that, then reject the null hypothesis. Now see one example. A sample of 180 persons with a particular disease was selected. Out of these, 120 were given a particular drug for high blood pressure, and the results are as follows. Okay. Okay. So now if we apply the drug, 80 are cured, 40 not cured. If you do not apply the drug, 20 cured, 40 not cured. So total cured person 100, total not cured person 80, total drugs given 120%, no drug 60, total is 180. Test whether the drug is effective or not with 0.05 significance level. Okay, so the solution is, null hypothesis H0 is, there is no relationship between two categorical variables, that is the drug is not effective. The drug is not effective because drug and cure, no relationship between these two attributes. And H1 alternative hypothesis, relationship exists between two categorical variables, that is the drug is effective. The drug is effective. If okay, so drugs and cure not cure, if they are related, that means the drug is effective. So these are nothing but our observed frequencies. Okay, and we have to draw the expected frequencies. So how to get the expected frequency? So already you know, 100 into 120 divided by 180. Here 100 into 60 divided by 180. Here 120 into 80 divided by 180, and here 60 into 80 divided by 180. So these are our observed frequency, but these are our expected frequencies. So we have to draw a table, another table, so where observed are there and expected are there, and we have to identify O square by E. Okay, so here observed frequencies are 80 20 40 40, 80 20 40 40, and expected frequency 66.66. so if you solve this one you can get 66.66. if you solve this one you can get 33.33, 53.33 and 26.66. And if you apply this particular formula, the values are 2.66, 5.33, 3.33 and 6.67, and the total is 18.0076. Okay, so the calculated value is 18.0076. Okay, now the degree of freedom r minus 1 into c minus 1, number of rows 1 2, number of columns 1 2, that means 2 minus 1, 2 minus 1, that is 1. Okay, so alpha is equal to 0.05, so 0.05 into 1. Okay, you can see if the degree of freedom is 1, if the degree of freedom is 1 and the table value is 3.84. Okay, so the theoretical value or the table value is 3.84. Since the table value is less than the calculated value, okay, so it's a right tail test. So already you know it's a right tail test. So theoretical value is 3.84 and calculated value is somewhere here 18.0076. Okay, so it is more than this, so reject the null hypothesis. Since the table value is less than the calculated value, hence reject the null hypothesis. That is that attributes are not independent, and we conclude that the drug is effective. Next example. An automobile company is launching a new scooter and maps out its advertising campaign to determine whether the model appeal depends on age group or not. The results summarized below test whether the model appeal and age groups are independent or not with 0.05 level of significance. Okay, now so you can see here that very young people like this particular scooter, 10 no, do not like, 7. Young people 40 likes this, 60 do not like. Middle age 90 like this particular scooter, 20 not like. Old like 50 like, 5 like and 3 not like. So total like 145, total not like 90. Total very young 17, young 100 people, middle age 110 and old 8. So total in that is 235. So null hypothesis, no relationship between two categorical variables is present. That is, the model appeal does not depend on the age group. Okay, the model appeal does not depend on the age group. Okay, and H1 already hypothesis, relationship between two categorical variable is present. That is, the model appeal depends on the age group. Okay, the model appeal depends on the age group. Okay, so we have to draw expected frequency, because we have the already we have the observed frequency. So how to draw expected frequency? So here 17 into 145 divided by 235, 17 into 135 divided by 145, sorry, by 235. Similarly here in this case 100 into 145 divided by 235, in this case 110 into 145 divided by 235, in this case 8 into 145 divided by 235. So we can get observed frequency and expected frequencies. Okay, so observed frequencies are, so already you know, observed frequencies are 10, 40, 95, 7, 60, 23. Expected frequencies already you know how to calculate. 17 into 145 divided 235, the answer is 10.48. Similarly 100 into 145 divided 235, that is 61.70, and so on. And here we are calculating O minus E by E square, O minus E square by E. So 10 minus 10.48 square divided by 10.48, the answer is 0.0219. Similarly 40 minus 61.70 square by 61.70, the answer is 7.6319. And if you calculate the total is 38.8343. This is our calculated value. So calculated chi-square value is 38.8343. Assume level of significance is 0.5 and degree of freedom. Okay, so degree of freedom will be r minus 1 into c minus 1. So number of rows are 2, so 2 minus 1, and number of columns 1 2 3 4, so 4 minus 1, so 1 into 3, that is 3. Okay, so 0.05 level of degree of freedom is 3 and the value is 7.81. Okay, since the table value is less than the calculated value, our calculated table value is 7.81. okay, and calculated value is 38.83. so this is the rejection region. Since the table value is less than the calculated value, hence reject the null hypothesis, and we conclude that the attributes are not independent, that is the model appeal depends on the age group. Next, chi-square test of the hypothetical value of the population variance. Okay, to test whether a random sample xi where I is equal to 1 to n has been drawn from a normal population with a specified population, assumed population variance, say sigma p square. Null hypothesis. So there is one population, we have taken one sample and its sample value, say sample variance is square, and we have to check whether this population variance is similar to sigma p square or not. So sigma p is our assumed variance. Clear? Now for two-tailed test, H0 will be sigma square by sigma p square. So sigma square is our actual variance and sigma p is what? Our assumed variance. Okay, assumed population variance. And for two-tailed test, null alternative was square. For right-tailed test, sigma square is equal to sigma square. Sigma square is greater than sigma p square. And for left tail test, H0 sigma square is equal to sigma p square and sigma square is less than sigma p square. Okay, now the calculated value, chi-square value is calculated value is n minus 1 s square divided by sigma p square, where s is the sample variance, s square is the sample variance, sigma p square is the population variance, n is the sample size, and degree of freedom is n minus 1. Degree of freedom is n minus 1. Okay, so if it is a two-tailed test, then it is alpha. So already you know chi-square alpha by 2 n minus 1. Okay, and here chi-square 1 minus alpha by 2 n minus 1. Okay, and so this is the acceptance region. And if it is a right tail test, then the table value is alpha n minus 1, and if it is a left tail test, it is alpha n minus 1. Okay, here it is minus 5. Okay, confidence interval. So 101 minus alpha percent confidence interval of the population variance is n minus 1 s square alpha by 2 n minus 1 sigma square n minus 1 s square 1 minus alpha by 2 alpha minus 1 n minus 1. Okay, so actual population variance would be in between this value and this value. Now example a class instructor believes that the standard deviation of the number of the students absent per day is greater than 5. A random sample of 12 days is selected. The data are 10, 3, 4, 6, 9, 2, 0, 2, 8, 7 and 1 and 5. At alpha is equal to 0.05, is there enough evidence to support the instructor's claim? Okay, now solution. The standard deviation, assumed standard deviation is 5. Okay, now standard deviation is 5, hence sigma p square variance is what? 5 square, that is 25. Now we apply right tail test here. So null hypothesis is what? Sigma square is equal to 25, and alternative is what? Sigma square is greater than 25. So H0 is what? The population variance is 25, and H1 the population variation is greater than 25. Now the sample data are 10, 3, 4, 6, 9, 2, 0, 2, 8, 7, 1, 5. Okay, and its variance, if you calculate the variance, its variance is 10.75. Okay, the sample variance is 10.75. The calculated value is what? In minus 1 s square divided by sigma p square. So n is 12 minus 1, s square is 10.75, sigma p square it is 25. The answer is 4.73. Okay, now the upper critical basically value, it's a right tail test. Okay, so it's a right tail test, so it will be square alpha n minus 1. Okay, chi square 0.05 and alpha is 12 minus 1, chi square 0.05 and 11. Okay, so you can see this particular table, chi square table. So degree of freedom is 11. Okay, and its value is 19.68. 19.68. It's a table value. Okay, and its calculated value is, we have calculated value is 4.73. Okay, so its calculated value is 4.73. so since the calculated value is less than table value, hence do not reject the null hypothesis. Next, it is believed that the precision, next example, it is believed that the precision of an instrument is not less than 0.05. A random sample of 10 instruments is selected. The data are 3.0, 3.32, 3.4, 2.6, 3.3, 3.2, 3.0, 3.2, 3.4 and 3.4. At alpha is equal to 0.01, is there enough evidence to support the claim? Now here we have to apply left tail test. So sigma square, null hypothesis, sigma square is equal to 0.05 and alternate sigma square is less than 0.05. So assume sigma is what? 0.05. Okay, so the data are given. The data are 3.0, 3.2, 3.4, 2.6, 3.3, 3.2, 3.0, 3.2, 3.4 and 3.4. The calculated, so you have to calculate the variance. So if you calculate the variance, its value is 0.0623. Okay, now the calculated value is n minus 1 s square by sigma p square. So total number of 10 samples are there. So 10 minus 1 into s square 0.0623. Okay, and assumed variance is 0.05. The value is 44.94. Okay, now the table value is chi-square 1 minus alpha. Okay, and degree of freedom n minus 1. So chi-square 1 minus 0.01 10 minus 1 chi-square 0.99 comma 9, and its value is, if you can see here, it is 9. Okay, and here it is 99, so 2.09. Okay, so the value is 2.09. 2.09. So here there is one mistake. It should not be negative, it should be positive. You can see here. Okay, it is from 0. Okay, so the table value is 2.09. Okay, so 2. And our calculated value is 44.94. Since it is in more than this particular table value, hence do not reject the null hypothesis. Okay, you can say, as we know the left tail test, then reject the null hypothesis. Since the calculated value is more than the theoretical value, there is therefore do not reject the null hypothesis. And that is the end of this particular video. Thank you very much.